for all of the questions, you're gonna have to upload your work, and ideally, I want it to be like for each question, it's gonna be just one file. So I want one question to have the answer for all 6 of them. Pretty much each one of them, I just want you to take a picture of the work that you did for that one particular problem. So don't do multiple question in a picture. I just want it to be one singular document for that one problem. Any question in regard to that? Sweet. All right. So let's go over to today's notes. So let me share the notes. Cool. All right, so those are the pretty much the practice exam. So let's go ahead and continue on with this one. So if you look at this next problem, this is the next problem. So this is pretty much the start of hypothesis, well, not hypothesis testing. It's gonna be, what you call it? It's gonna be confidence interval. There we go. So that's great. So if you look at the problem, it says for the CSUDH senior student population 65 and over, the value of a standard deviation is 24.56 years old. All right, so if you kind of notice for this one, here's the sentence. So if you look at it, they gave us a standard deviation of 24.56. But if you look at that sentence, does they say anything about a sample, or do they tell you how many people did they sample? Like, no. They don't tell you that they took a sample of like 10 seniors or 20 senior from CSUDH. Pretty much they're saying that it is 24.56 years old. So that's our standard deviation, but more importantly, that's of the population. So that's 24.56. All right. And then if you look at it, it says a sample of 16 observations from this population is produced for the following data. So you got 74, all of this. All right. So if you look right here, here is our data. All right, so if you look at A, it says constructing 90%, 95%, 99% confidence interval for the mean age of CSUDH senior student. So if you look at it, we want to construct a confidence interval. So since we want to construct a confidence interval, we're going to be doing this into class calc. So the first thing in class calc, we have to enter this data. So let me get class calc ready. All right, so let's go ahead and transfer over to class calc. All right, so the first thing I want to go ahead and do, just enter our data set. So I want to say x1, and let's say x1 is equal to this data set. So we put 74, 85, 68, 73, 83, 68. All right, so that's my data set. So if you look at our data set, I have 16 elements, so that means we have 16 numbers. So now what I want to go over here, I'm going to go to this new line, and now we're going to go to stats again. For this one, you have to go to test. So remember, for this one, we could do two options. We could do the Z interval or ZINT, or we could do T interval. So for this one, since they did give us the population standard deviation, you want to do the Z interval. So for the Z interval, we put sigma, which I know is 24.56. But if you look at it, I have to change it because I don't know what the sample mean is. So I want to change this to data. All right. So we got 24.56. And now I'm going to tell I'm going to tell the class cal to look at the data set. So it can look at X1. And now all we have to do is change our confidence level. So we want to do 90%, so we put 0.90. So if you look at the answer we get for 90% confidence interval, it gives us from 65.46309 all the way to 85.661901. Also, if you look at it, it also gives me the margin of error. Because if you look right there, it says ME. So if you want to find margin of error, that's your margin of error. So 10.09940127. So let's see, I think I got something on the chat. What does the L represent? L represents the list. So L represents the list of data sets. So since we have this list on the top row that I named X1, that's why you put X1 into L, because you just want the list. All right. But that's how you do it for 90%. So if you actually look at the problem, they also want you to do it for 95%. So if I want to do it for 95%, we'll just change that up. And now we have it for 95%. Cool. So for 95%, we'll say is 63.528,321 all the way to 87.59667. And also, if you look at the margin of error is equal to 12.03417887. All right, and that's for 95% confidence level. But if you actually look at your study guide, we also want to do that for 99%. So for 99%, we'll just change this from 95 to 99%. And now we have that. So now saying is from 59.746908 all the way to 91.378,092. And my margin of error for that one will be 15.82. All right, so that's how you want to do it with class calc. Any questions so far on how I got any of the answer using class calc?
No, sir.
All right. And just a reminder, like if I don't tell you to do it by hand, just do it with class calc, because class calc will save you so much time. And there's little to no chance of you getting it wrong if you do it with class calc versus if you do it by hand. There's more chance of error because there's more chance that you might do something that's not correct. All right, so that's what I wrote. So if you look right here, here you go for 90% confidence interval. Here you go for 95% confidence interval. And lastly, here's 99% confidence interval. All right. So if you look at part B says, what is the margin of error at each of the confidence intervals? So For part B, it is asking for this, which I already put right here. So pretty much all you put like a little arrow signifying that this go for part B. All right, but that's it for that problem. Any question in regard to that last problem? All right. And let me put right here that we use the interval. Good. So just remember for this one, like the key thing that it's telling us we want to do a confidence interval. So as soon as they tell you we want to do a confidence interval, you should know it's either going to be the T interval or the Z interval. And in order to decide if it's the T interval or the Z interval, a T interval, you use it if you have sample standard deviation. But if you have the population standard deviation, that's when you use the Z interval. So you should kind of make like a little note on that for that way on the test, you should be able to get this correct. All right, but let's move on down. All right, so for this one, it says for the following, state the null and the alternate hypothesis for each of the following examples. Determine if each is a case of a one-sided or two-sided. All right, so let's go ahead and do this one. So if you look at this one, all we want to do, we just want to list the null and alternate hypothesis. We don't want to solve for anything like that. We're essentially just going to be looking it over and seeing what is the null and what is the alternate hypothesis. So let's go ahead and do this one. So let's say HO, H, well, we say H1. So it says for the following, state the null and alternate hypothesis. So to test whether or not the mean price of houses in Connecticut is greater than 143,000. So if you look at this one, we want to test to see if the mean price of houses in Connecticut is greater than 143,000. So that means my alternate hypothesis would be mu is greater than 143,000. So my null hypothesis will be mu is equal to 143,000. Please remember your null hypothesis is always stating there is no change. So there is no change, you put that equal to it. But for the alternate hypothesis, you want to state there is a change, and then you state what the change is. But any question for the first null and alternate hypothesis? All right.
No, sir.
So let's go on to the second one. So it says to test if the mean number of hours spent working per week by a college student who holds a job is different from 15 hours. All right, so if you look at this one, is the mean number of hours spent working per week. So we're gonna say HO, HA. HO, we're gonna say mean is equal to 15 hours. But if you look at my alternate hypothesis, the alternate hypothesis is you're going to state we don't think it's 15 hours. It could be greater than, less than, or not equal to. But in this one, since it's a different, we're going to put not equal to 15. And that's it for that part B. Any question for part B?
No, sir.
All right, cool. All right, so let's go on to the next question. Also, just a heads up for the test, it's gonna be formatted this way. So if you are doing a hypothesis testing, it's gonna ask you to take the null and the alternate hypothesis, calculate the Z statistic value, determine the P value, and pretty much just state a conclusion. So you kind of want to work in this format. All right, so let's go ahead and see this problem. So it says the management of Priority Health Club claimed that its member lose an average of 10 pounds within the first month after joining the club with a standard deviation of 2.4 pounds. A consumer agency that wanted to check this claim took a random sample of 36 members of this health club and found that they lost on average 9.2 pounds within the first 2 weeks. So the first thing you always want to go ahead and do, just go ahead and get all of the number and just go ahead and just label them all. So we have, oops, sorry about that. So we have 10, we have 2.4, what else do we have? We have 36, and lastly we have 9.2. So we want to just go ahead and just label all of those values. So let's label the easiest one. What is 36? What symbols or how should I notate that?
That's N.
N.
Yeah, that's N. Great job. All right. So if you look at it, here you go, N. So N is in this sentence. It's a very long sentence. So if you look at it, that's the sentence where they give us N. So what other information do they give us? Well, if you look at it, they also give us 9.2. So that's 9.2. So since they told us we have a sample of 36, and since they gave us 9.2 from that 36, you should already know this is a sample. But now what we have to do, we have to figure out if this is a sample mean or a sample standard deviation. But if you look right in front of it, it says average. So that means this is a sample mean. Because pretty much this 9.2, they got it from these 36 members. Right. So we know X bar is equal to 9.2. What about 2.4? What would 2.4 be?
Standard deviation.
Standard deviation.
Cool. All right. But is this standard deviation of a sample or the standard deviation of the population?
Population.
Perfect. Population. So we put sigma right here. Okay, if you look at the 2.4, if you look at that, nowhere in the sentence where they give us a 2.4 do they tell us, hey, we took a sample of 36 and we got 2.4, because the sample is in this sentence. All right, so that's 2.4. So that means 10 has to be our population mean. Cool. And the good thing about labeling all of this, once you label everything, it makes it so much easier to actually do the problem. Because once you have to start substituting stuff, like say putting it into class cal, it's gonna be so much easier to be able to put it into class cal because you already have everything labeled and you don't have to kind of second guess yourself. So let's do the known alternate hypothesis. So the known hypothesis is pretty much this. So the null hypothesis is that mu is equal to 10. Okay, so cool. So let's do the alternate hypothesis. So you put mu, you put 10. All right. So for this one, do they kind of give us any indication that it should be greater than or if it should be less than? Well, if you look at the problem, they don't really give me any indication that they think it should be greater than 10 pounds or less than 10 pounds. So since they don't give me any indication if it should be greater than or less than, what we're gonna do, we're gonna assume that it's just different. So we're gonna put that it's not equal to. Everybody good on not equal to? All right, so now for B and for C, actually you're gonna do this in class cal. So in class cal, let's go over to class cal. Oops, I forgot to share class cal. So you can't see it right now. All right, so I'm gonna go ahead and just erase all of this, yes, to make it look nice. So we're gonna go to stats. We're gonna go to tests because you want to do a test. So just remember for tests, you have two options. You can either do a t-test or a z-test. In our case scenario, since I know the population standard deviation, you're gonna do a z-test. So if you look at the z-test, they give us all of this information, so we're gonna leave it in stats. You only do data if they give us a data set or raw data. So for this one, we'll put mean is 10. We'll put standard deviation is 2.4. We go x bar is equal to 9.2. And lastly, n is 36. All right, so that's what's popping up for me in ClassCal. Any question on how to enter this into ClassCal? All right.
No.
So if you look at it, I'm going to use this one right here, the one that says not equal to, because if you remember for my alternate hypothesis, we use a not equal sign. So that's my p-value. And then if you look right here, z a -2, that's going to be my test statistic. So for part B, I'm going to put z is equal to -2. And then for p-value we're going to put is 0.0455. And usually when you're getting p-value, it's kind of like the good rule of thumb is you always get 4 decimal places. So for this one, if you look at it, it will be 0.0455. All right, but that's it for ClassCal. Any question on what we did for ClassCal? All right, so let's go ahead and transfer back to my notes. So if you look at my notes, I put B is my Z value, C is my P value. So now what we have to do, we have to write a conclusion. So this is where some of you kind of messed up for the last quiz. For the last quiz, some of you forgot to put a conclusion. Could you put like reject a null hypothesis, or you put fail to reject a null hypothesis? But you didn't write a conclusion, so be careful with that, because if you don't do a conclusion, you're not going to get credit or full credit for it. So if you look at this one, it says test the 3% level if the average weight loss for Priority Health Club member is different from 10 pounds. So for this one, they're giving me alpha. So alpha is 0.03, p-value is 0.0455. So which one's bigger, p-value or alpha?
P-value.
Yeah, great job. So p-value greater than alpha. So for this case, you say fail to reject HO. So if I fail to reject HO, that means there's not enough evidence. So we'll say there is not enough evidence to support So there's not enough evidence to support the claim that it is not 10 pounds. And that's it for D. Any question in regard to D? So you kind of get used to this format, because like for the test for tomorrow, it is going to ask you to put like first put the null alternate hypothesis, then put the test statistic, then put the p-value, and then lastly, you have to make a conclusion. All right, so that's it for that.
I have a question.
Yeah, what's up?
When do you use a fail to reject and then the normal reject?
So for the fail reject, if you remember in the notes, pretty much if p-value is less than alpha, that's when you want to reject HO. When p-value is bigger than alpha, that's when you fail to reject.
Okay, got it. Thank you.
But yeah, but this should also be in the notes. If you go to like the last notes that we had, and it should be under something like rule of thumb or something like that. And I also put it there. All right, so that's it for this last problem. Any question for this last problem? All right, so let's go ahead and do the very last problem. So for this one, it says, let me take away the chat. There you go. So it says a study conducted a few years ago claimed that adult males spend on average of 11 hours a week watching sports on television. A recent sample of 100 of those showed that the mean time they spend per week watching sports on the television is 9.5 hours, with a standard deviation of 2.2 hours. So let's go ahead and let's make note of all of this. So we have 100, we have 11, we have 9.5, and we have 2.2. All right, so let's do the easy one first. What does the 100 signify?
N.
And perfect. So you should always try to find N first, because N usually should be the simplest one to find, because it will say like we survey 100 people or we sample 100 people. But it should kind of let you know that they took a sample of how many people. So always look for N first. That's like the easiest one. All right, so if I look at which sentence did it give me N, isn't this sentence right over here? So if you look at that sentence, they also gave me 9.5, but they also gave me the information of 2.2. So that means both of those information is coming from the 100. So both of those will be a sample. So that means 9.5, if you look at it, it said the mean time they spend per week watching sports on television is 9.5. So since that's the mean, and since it's coming from a sample, we put X bar is equal to 9.5. If you look at 2.2, that's the standard deviation, but since it's coming from the sample, this will be considered S. And lastly, that means 11 should be considered mu. All right. Any question why 9.5 and 2.5 are pretty much sample mean and sample standard deviation? All right. So since we have a sample standard deviation, that means we're going to be using the t distribution, but we're going to be using the t-test. So that's how you know if you should either use a z-test or a t-test. In the last one, in the last problem that we did for number 10, since we have the population standard deviation, that's why you want to do the z-test. But for number 11, since we have a sample standard deviation, you're going to want to use a t-distribution. All right, so let's state the null and alternate hypothesis. So the null hypothesis should be is equal to 11. For the alternate hypothesis, should be right here. So if you look at it, it says test at the 5% level is significant if currently all adult males spend less than 11 hours. So this is what we want to test. You want to test that it's less than 11 hours. So right here, you put mu and you put less than 11 hours. Any question why mu is less than 11 hours? All right. So now we're gonna go ahead and we're gonna switch over to class calc because we need to make these calculations. So we're gonna get the t value, but we're also gonna get the p value. So let's erase this. So we go to stats, we go to tests, and we go to the t-test. So for t-test, we'll say mu is 11. We'll say X bar is 9.5. We say S is 2.2. And lastly, we say N is 100. All right, so if you look at the t value, here's my t value. So we get negative 6.8181818. If you look at our p value, it essentially gave up, and it's from like p value is equal to 0. So if you look for our test statistic, we say t is equal to negative 6.818. If you look at the p-value, well, p-value, it just gave up, and it says 0. Everybody good on my test statistic and p-value?
Yes.
All right, so let's go ahead and switch over. So we'll go here. All right, so if you notice, all I did for part B, I put the t value, and for C, I put the p value, which is 0. All right, so if you look at part D, they gave me the alpha, which is 0.05. So if you look at the two values, you just want to see which of the two is bigger, p value or alpha. So you can kind of clearly see alpha is bigger than p value. So if you kind of look back to these rule of thumb, if alpha is bigger than p value, we reject the null hypothesis. So in this case scenario, since alpha is bigger than p value, we reject HO. Any question how we reject HO? All right, so lastly for part D, it says test at the 5% significant level if currently all adult males spend less than 11 hours watching sports on television. So for this one, you just want to say there is enough evidence to say that all right. So for this one, we'll say there is enough evidence to say that the mean time males spend watching sports television is less than 11 hours. And the reason why it's less than, since we reject the null hypothesis, we mean we reject this and you conclude the alternate hypothesis. So the alternate hypothesis is stating that the mean is less than 11. So that's how you want to do the conclusion for this one. And that's it for that one. Any question in regard to that conclusion?
No, sir.
All right. So that's it in regard to this study, guys. So that's what the test is going to cover tomorrow. So here, let me go on Blackboard. Yes. All right. So for tomorrow, I'm going to show you where the test is going to be at. So that way you know exactly where to go. So that way there is no confusion about where the test is. So let me just log into Blackboard. And also just remember for the homework and for all the activity, they're gonna all be due tomorrow. So hopefully you have been working on the homework and on all the test activities. So that way you should have hopefully finished it all on Monday. But just know if you haven't, you have all the way till tomorrow to be able to do it. All right. So if you go to Blackboard, this is the first thing that pop up. So you have to go all the way down. And if you look right here where it says exam number 3, just click it. And what you want to do, you're going to be doing test 3. So once you do test 3, once you open it, let me see how many minutes does it give you. So if you look at this one, I'm going to give you an hour and 30 minutes to do it. So you should have enough time to be able to do the problem and then just upload the problem. So for this one, yes, no, for this one, there's going to be 6 questions. So it shouldn't be that bad. But yes, no, for the question, they are going to have multiple parts to them. So it's going to be like doing part A, part B, part C, so on and so forth. But it shouldn't be that bad. So this is where I'm going to input, well, this is where test number 3 is going to be. So you go to exam 3, and then you do test 3, and it should be available tomorrow from 12 p.m. all the way to 10 p.m. Also for today's lecture, will be in week number 6. So right here, I'll put the video lecture up today. And then I'll also have a other folder right here where it says week 6 notes annotation. And that's where I'll put the answer for the study guide. So in case I went a little bit too fast for you on the study guide, you could go back and look at the study guide to make sure that you understand the study guide. But that's pretty much it. Any question in regard to anything?
I noticed for the pre-exam that we had a time limit on it. Do we just ignore that?
Yeah, just ignore it because essentially what you want to do, just because you're not submitting that, all you have to do is just download it and just work on it. Does that kind of make sense?
Yeah, that makes sense. All right, thank you.
Yeah, I think I just forgot to take out the time limit, but all you just need the file. So once you get the file, you're set to go. Like you don't have to submit it for homework or credit or anything. It's just for you to practice.
Oh, okay. All right, thank you.
Yeah, you're welcome. Any other question?
So we don't have class tomorrow?
Yeah, for tomorrow, essentially I'm gonna do like office hour. So I'll be in Zoom from 10 to 11:30, and I'll be there in case you have any question about anything. So if you want to go over any last minute question, but for tomorrow, there is no class. So for tomorrow, since there is no class, it is office hours, there's not gonna be a recording for tomorrow. But yeah, so no class tomorrow, essentially just office hours. Any other questions? All right, so what I'm gonna do right now, I'm gonna close down this meeting and I'm gonna go to my office hour meeting. So if you do have any question you wanna ask me during office hour, I'll be there. So that's it for today. So have a good day and if I don't see you tomorrow, good luck on tomorrow exam.